Okay, so our next step for our autonomous bot is now finished, right? So this is going to be the brain of our little bot. This is an GeekCom or an ASUS AS6. It's a 4 gigahertz processor, 32 gigs of DDR5 RAM. Basically, we're going to be running I don't know, AI-ish algorithms onto this thing and then making this vehicle move based off of its decisions. So we used to use Raspberry Pis. Again, I have Raspberry Pi 4 vehicles, but you know, when you spend 55 bucks for a computer, as they say, you get a $55 computer. When you spend $700 for a computer, you get an actual computer. Anyways, so this is nice and small. You see the size of it. Yesterday, the test that we did is I ran OpenCV continuously with object detection on for the face, while this was just plugged into here. So basically it was getting all of its power from there. And what we found is we got at very least 2 hours of battery life of this little thing doing its OpenCV. So anyways, with OpenCV, basically it's able to detect an object, it's able to detect the XY coordinates of the object, and then we can use Python in order to move a vehicle or basically do something based off of those XY coordinates. So now we are working on the drive subsystem. So whenever you're dealing with robots or any of these types of things, you have the systems and the subsystems. The idea is basically you have a subsystem, this whole component here, that will be able to communicate with that computer that's responsible for something. And so what I will say is when you're dealing with sensors, when you're dealing with motors, when you are dealing with physical inputs and outputs, Arduinos are frickin' awesome, right? You know, again, even with Raspberry Pis, you can add ultrasonic distance sensors and those types of things. But when you look at the wiring and you look at the requirements of getting sensors and things to work on a Raspberry Pi, you think, wow, that's so much simpler on an Arduino. So we're using the Arduino as the drive subsystem. So the wires on this Arduino are plugged into the H-bridge. The H-bridge then has power coming from the battery pack. It's going through this converter, coming here, and then we have power that then goes to the wheels. So basically, this Arduino is able to control the wheels to go forward, backward, left, and right. But here's the thing. So this is here, and that is there. How do they meet? Which is the next question. So what we're going to be using, at least for the very first iteration, most likely continuously, unless somebody gives me a better idea, is using the serial communication, right? So you can actually use serial communication to both read and send information to your Arduino. So this Arduino is literally plugged into this iMac. And basically what I can do is using the serial monitor in here, I can send commands to make this go forward, left, or right. When we're doing it with this, there is a serial module. So in Python, there's a module, I think it's called serial, and with that, you can actually read and send serial commands. We're using the serial monitor right now because that's what we've got. So this is the Arduino IDE. Basically, we deal with the pins, left, forward, left, backward, whole 9 yards. We create a string for the command. We start the serial begin. So this starts the serial monitor. It'll print out on the screen, you know, forward equals F, backward equals B, left equals L, right equals R, or S equals stop, yeah. We do the pin modes, and then we do this loop down here. And what's curious with this, what's really kind of cool, if we take a look at this, right? So if serial is available, so if the serial communication is available, command equals serial read string until next line, command.trim, so that trims out all the white space, right? So if command equals F, we go forward. If command equals B, we go backward. If command equals L, we go left. If command equals R, we go right. If command equals stop, we stop, right? And so if we take a look at this, So I have the serial monitor down here. Again, this will be sent through the Python script when we get it going. So basically what you can see is I can do, so I can hit F, see F, but then its next line is when it takes command and enter. Okay. I can do write, enter. I can do B, enter. I don't know if you can really see that. And then I can do S, enter. So therefore, I am able to send commands to the Arduino as simple strings. It reads that strings and then it turns the motors on and off. So right now, the motors are either on or they're off. So it pushes the max power to them since it's on or off. In the future, what I'll play with is there's something called pulse width modulation. So pulse width modulation is essentially like a digital dimmer for motors and things when you're dealing with Arduinos. That's something, we'll deal with. We'll deal with. So now that I have this, now I need to go and look at the Python code, add to the Python code to read the XY coordinates of the object. Depending on if the XY coordinates are too far to the left or too far to the right, it will then need to send a serial command to that. And hopefully pretty soon we will have, a relatively decent object tracking little robot here. So anyways, and again, this is one of the big things, with people who want to get into technology and especially do interesting things in technology, and they always say, Eli, what language should I learn? Or what product should I learn? I mean, just look at this for a second, right? So this is a Linux box that's running OpenCV that's processing everything through Python. That's then sending serial communication to an Arduino device where then we have to write everything in this C-ish type code. And then we also have to understand how to do things such as power the motors and do pulse width modulation and all that kind of stuff. So if you're sitting there and you're asking yourself, Eli, what language should I learn to become a tech professional? It's like, well, just, a few. Find the ones that will solve the problems that you're trying to solve. For me, I'm trying to build a goofy ass little robot. So anyways, it's only 3 o'clock. I might actually be able to do something a little bit more significant today. So if you like these types of videos, give us a thumbs up. If you don't like these types of videos, give us a thumbs up. And I'll see you all later.